graph of the tangent function, but bearing in mind that tangent is sine over cosine. So if we have the graph of the sine function here, quick sketch of the graph, negative 1, 1, 0, pi over 2, pi, 3 pi over 2, 2 pi, etc. And going backwards. The graph of the cosine, got this in blue here, on the same scale. Now, knowing that tangent is sine over cosine, let's build this function. If tangent is sine over cosine, anytime we have division going on, what's going to happen to this when the numerator is 0?
It's going to be 0.
That's right. So any place that the sine is 0, what's the graph of the tangent going to be?
0.
0. 180 degrees. Or every pi radians. Now, what's going to happen when the cosine is 0?
Undefined.
Undefined. Which graphically means what? We put a what there?
Asymptote.
An asymptote. So, wherever the cosine is 0, we're going to have an asymptote. So I'm going to change this to blue, because where cosine is 0, tangent is going to be undefined. So the cosine is going to have, or the tangent, the graph of tangent is going to have an asymptote in these places. And obviously, if this is a sketch of the graph, I am not an art major, and so my drawing skills are not nearly as great as certain other people's are. And I'll erase these black lines. These black lines are just to help line things up. Okay, so what we have now is we have places where the graph of tangent is 0, and we have asymptotes on the graph of tangent. So let's see what we do with this. Let's do this. Let's go right here next, right to the left of this asymptote. What happens right next to this asymptote? Sine is what sort? Describe what sine is doing as we approach as we approach pi over 2.
Increasing.
It's what?
I said increasing.
Yep, it's increasing. What did you say?
I said it's peaking.
Yep, it is peaking. It's peaking. It's increasing toward what value?
1.
1. So it's getting larger toward 1. Meanwhile, what is cosine doing as we approach pi over 2?
Getting negative to 0.
It's
Or decreasing.
decreasing. Yeah, it's not negative yet. It's negative here, but it's still positive. But it's getting to be a very, very, very small number. So we have a positive number that's getting larger toward 1, a negative number, or a positive number that is getting smaller towards 0. So what happens to a fraction as the numerator is increasing and the denominator is decreasing? What happens to the value of the fraction?
It gets bigger.
That's right, it gets bigger and bigger and bigger. Okay, so I'm just going to put a little, so if this is an asymptote, let's assume that let's just say that it's going to do that. All right, let's come next to this, the other asymptote over here. What is happening to sine as we approach this asymptote? Is it positive or negative?
Negative.
And is it increasing or decreasing?
Decreasing.
Decreasing. So it's getting smaller, or it's decreasing. What you can also think of as it is getting larger in the negative direction. Meanwhile, what is happening to the cosine function as we approach this asymptote, or as we approach negative pi over 2?
It's positive but decreasing.
Okay, it's still positive but getting smaller and smaller. And so a smaller and smaller number on the bottom is going to make for a larger and larger number when we're talking about the fraction, in this meaning tangent. So a larger and larger number, but we have a So we're going to have a larger and larger number in a negative direction. So we're going to be we're headed this way next to this asymptote. So, and if we know we cross here, it looks like this. All right, so let's jump across this asymptote. What is happening just to the right of pi over 2? What is sine doing?
It's getting smaller.
That's true, going this way, but let's just to the right of the asymptote. So what happens as we are approaching this asymptote from the right? I probably should have phrased that question better at first. What happens as we approach this asymptote from the right?
It's getting bigger.
It's getting bigger. Are we positive or negative?
Positive.
Okay. What is happening? You know, I probably should do.
Purple.
Purple. I should probably point this out. Positive, negative, positive, negative, negative, positive. This one, negative, negative, positive, negative, negative, positive, positive, negative, negative, etc. So just filling this in here. If we have a negative divided by a positive, this is going to be negative. A positive divided by a positive is going to be positive. A positive divided by a negative is going to be negative. So we're going to be down here. Negative divided by negative is
Positive.
positive. Okay, so coming back to here, as we approach this asymptote from the right, we are getting larger. As we approach this asymptote from the right, we are getting smaller. In terms of absolute value, we are getting a smaller and smaller number. It's increasing. If you think of a number line with 0, negatives, and positive, we are moving this direction. So we're getting great. We're getting greater, but in terms of absolute value, for moving from here over this direction toward here, the absolute value is getting smaller. Right? We're getting it to be a smaller and smaller negative number. So again, smaller and smaller number on the bottom. Ignore the SIGN for a second. A smaller and smaller number on the bottom of a fraction is going to make the fraction be larger and larger in terms of absolute value. So if we know that, if the absolute value as we approach pi over 2 from the right, if the absolute value is getting larger, and we have positive divided by negative, which gives us a negative, so we're going to get a larger and larger negative number. Over here, as we approach this asymptote from the left, we have a negative divided by a negative, so that's going to give us a positive, so we're going to be up here, between here and here, between this 0 and this asymptote, we're going to be on the top side of the x-axis. As we approach this asymptote, the sine function is getting to be a larger absolute value number. Cosine, as we approach this asymptote, is getting to be a smaller absolute value number. So as the denominator gets smaller, the number that the fraction equals gets bigger in a positive direction. And so we have this again. And I think red is turning diagonally. Check the stash. I do have a red. So what do you think is going to happen between these two asymptotes?
It's going to be the
Same
same.
thing.
A good call. So same thing. Come through here, hit there, and go that way. And we just have a repeating pattern like this. Since sine is cyclical, so cosine is also cyclical. Tangent is also cyclical. Now, what's one difference, though, between the cycle of sine and the cycle of cosine? What does the cycle of sine and cosine have in common with each other that is different from the cycle of tangent?
They're always like repeating. I mean,
Yes, they are always repeating. What is the period for the sine function?
180.
How long does it take to get through one complete
360.
rotation, one complete cycle through all of its values? 360 degrees or 2 pi radians. If we start here, on our way up, we go up, we come back down, we get to the bottom, and we come back up here, and here's where we start repeating the cycle. So we have a period of 2 pi. What about cosine? What's its period?
360.
60.
360. What's the period of tangent?
180.
180. Okay, so if you know what sine looks like and what cosine looks like, and the fact that tangent is sine over cosine, you can construct the graph of tangent fairly easily. And that's what it looks like. And make sure that anytime you do it in your homework, that you do it in multicolors like this. You take up a lot of space. Just we're done. Thanks.